Well, thank you, everyone. Oh, perfect. This is what I need. Well, I'm really excited to be here, and it's fun to talk about this. So I was in I was doing concierge medicine for a few years, and I saw people doing really interesting, maybe some really expensive stuff, and then some really weird stuff. And so it made me think. It is like, can we do something where we blend primary care with longevity medicine and do it in an academic way? So that was the origin, and this is why I co-founded PrimaryMD. So my talk is buyer beware, balancing hype with integrity, because there's a lot of weird stuff out there, and there's also a lot of great stuff out there as well. So what I want to start with is anyone know what this is? It's a snake, yeah. This is a Chinese water snake. It's a Chinese water snake. And so what's very interesting about this is in the 18 this is something that I just learned putting this talk together. When I put a lecture together, I always love learning something. So it turns out that the Chinese immigrants, while working on the railroad with traditional medicine, would smash up or get snake oil from a Chinese water snake and then use it as a balm. Rub it on their sore joints, rub it on their arms, rub it on their legs, and it was thought to work. And what's extremely fascinating is this water snake has got about 20% omega-3 fatty acids. So potentially it actually worked. And then something else happened from there. As you can imagine, there weren't that many Chinese water snakes in the United States, especially along the railroad line. So people started using rattlesnakes, and then rattlesnakes had about an 8% rate of omega-3 fatty acids, and then it goes downhill. Then they started using mineral oil mixed with beef fat and mint and stuff like that, and this is where we are: snake oil. And that's sort of the origin of snake oil. It came from something where it actually probably worked, or maybe it worked, or maybe it was a placebo effect. But something happened that made people want to use this. And I'm a huge believer that the placebo effect should be renamed to the effect of positive expectation. But maybe it worked, maybe it didn't. It's very interesting about the omega-3 fatty acids. But what happens these days now? What happens these days now? When we see something, you have a rodent study. And then what happens after you see a small little rodent study? You see a podcaster these days talking about how something can work. And then an influencer markets it, and then somehow somebody somewhere profits on it. That's what we see. And Earlier today, John over there mentioned John Ioannidis about a paper that he said why most published research findings are false. Has anybody read this paper? I got 1, 2. I think everybody in the longevity space should read this paper. So like, why most published research findings are false. It is very well done. It's a little mathematical, but the idea of it is incredible. So if you haven't done this would be one thing for anybody that's interested in this space to read. Read it, understand it. Put it in ChatGPT, ask the large language model what it means, do something, but get something out of this. But what you see is a few different things. Is when you see small effect sizes and small studies, you're going to get some positive studies that way. And then the other thing that you see, I'm not sure how many people here are in data analysis. There's probably a few people there. And it's like you could manipulate data and find somehow where you get a p-value of less than 0.05 by putting in different variables, by plugging anything in. What happens then? Then you get publication bias. It is like, is it interesting? Would it be interesting to anybody to say, is like, oh, I took magglycinate and it did nothing? Would that be interesting? Would someone publish it? Absolutely not. It will not. And this is why publications have changed a little bit, but there's definitely publication biases. And then one of the other things that I think is critical is conflict of interest. Who is the person talking about this, and how much money? Are they making money? Yeah.
That's true.
Yeah. They're making money, and what else? Are they And the other thing that people don't talk about, are they doing this and are they moving up the academic ladder with this as well? That's not talked about either. We often talk about pharmaceutical companies making money, but you forget about academic bias. You forget about other kinds of bias. So always think, who is making money out of this? Those are really the big things. And the other way I like thinking about this too is, what is the pre-test probability? You know, like if something comes out and it looks like, wow, this is working, but the mechanism doesn't make sense, it's like, this makes no sense. It's like, did I think this was going to work? And then this paper comes out and it says it's going to work. Do you think that's going to actually end up being truth? No, probably not. Maybe down the line it will be, but be very, very doubtful. Now, if we're looking at this, let's go back a few years. And it's like, remember the antioxidant phase where it's like vitamin E, beta carotene is going to help you with all cancers. What ended up happening with that? Those were initial smaller studies. What ended up happening when it was studied in a much more controlled way? They actually found that vitamin E and beta carotene at the doses that people were given at the smaller studies actually maybe even increased mortality in some way, maybe actually increased causes of cancer. So think about that. Growth hormone, years ago, thought to be fountain of youth. Probably not very good for most people. Other things is like, who remembers about, or maybe who actually starved themselves 20 years ago because they found that mice that ate very little live 50% longer. Do you guys remember that era? Yeah.
Even in the 70s, Dirk Pearson and Sandy Shaw.
Yeah. And we think that's a good, and now maybe some people will live long. I mean, it's definitely not good to eat too much, you know, but starving yourself is probably not a great idea. And then you start thinking about resveratrol. You know, like that might be working on the same mechanism as caloric intakes. Does that turn out to be working? No, but there was so much stuff 20 years ago. There were papers on it, small papers. So if you guys get anything out of this talk at all, read this paper and look at stuff. Look at the longevity world and the framework of this. So think about it this way. And so what are we seeing? What are we seeing now? Another thing that you can get out of the biotech world is something called the hype cycle. And it's like something comes out, and it's like all of a sudden, everyone's using it. It's like an influencer. Influencer puts it out. It's like, oh, this is going to be amazing. And it's like things like NMD or NAD, rapamycin, metformin, you know, stem cells for everything. You know, IV stem cells for your joints to regrow cartilage, all of this stuff. There's so much out there. And then all of a sudden, we find out it's actually not working. And then hopefully, and this is what I do hope, is there's actually an area where we find out that there's something in there that actually does work. Because these initial studies might actually have shown something. They might have shown a signal of something. And then it actually, maybe there's going to be analogs. Maybe the rapalogs will actually work really well when studied, but who knows? You know, stem cells. We're learning so much more about it, but we do know that if you have a bad knee and you're injected with mesenchymal stem cells, it's not going to engraft in your knee. It's not like a hemopoietic bone marrow transplant where you clear out the bone marrow, you're going to get someone else's bone marrow. This is just all the goodies in the stem cells that are going to be doing that. It's not actually engrafting. So maybe it will do something. So I'm starting a primary care. I started a primary care company with longevity. So I think there's something out there. So I'm not a complete naysayer. I'm not a complete naysayer about everything. There are definitely exciting things that are going on. And one of the things that you do see is clinics are definitely pressured to offer the latest and greatest to stay competitive. And this is one of the reasons why I want to do this in an academic way. And I've heard this so much here is like people are reactive. You know, primary care offices are reactive. And, you know, this is why we have Function Health. People are like, oh, I'm going to go get my blood drawn. You know, this is why you have so many different direct-to-consumer places, because the way the model right now just isn't working for people. And obviously people here are taking a lot of things in their own hands. And you can't wait for, I mean, you can't wait for a study to come out to show everything works. Then we're going to be behind the 8 ball. And so really, people should be curious, really curious about what's going on. And we are definitely in an age where there's transformative things that are going on in biotechnology, in brain health. There's so many ways that are coming out there. But, people are using AI. There's the different. It's just a really exciting time to be in this area. So I'm definitely not a naysayer. So we got to move forward, but you got to build the evidence. You have to build the evidence behind it. And so, I guess one thing for disclosure for me, I run a primary care company, and I believe that what we're doing is we're trying to build back what it was like to have a doctor 50 years ago with all the new technology and the advanced stuff that's coming out right now. So that's my disclosure. So that's my bias, and I'm kind of wondering what everyone else's biases are also. We're seeing all these direct-to-consumer labs. Is this an innovation, or is this a reaction to just the horrible care that people are receiving? The 15-minute doctor visits. We really do need to do better. And then we're talking about AI, but what can AI do? What can AI not do? What I think at this point right now, when you're getting a number. When you get a number, it just tends to be noise. Without a real human narrative behind it, it just tends to be noise. Who here has done like some of these direct consumer, many people here. I'm probably everyone. Yeah. Who hasn't done function? Who hasn't done Mito? Who hasn't done anything? Like, who's done only what their doctor told them? Anyone? That's great. That's more than I thought. I thought there was going to be 0. But we are in that age where people are trying to do. They've been forced to do that, and that's the community. That's what's going on right now. What I think is really funny about this is my trainer. He got his function labs back, and it told him, you have to work out more. It said, you have to work out more. It's like this guy's in the gym like an hour and 15 minutes, 6 days a week. And I was like, hey man, maybe you should do this, not me. But really, it's like if you're just getting this without content in the background, it just doesn't make sense. Or at least that's my bias. And so we're in a world right now, and you're hearing a lot of people here talking about funding. We have to fund longevity science, and is aging actually a disease? And I'm a very strong believer in the way to do this is make people believe in this truly is a real. This is a real science, and have people believe in it. That way funders will come behind it. And we're already seeing that momentum. But I encourage everyone really to build it through evidence, replication, and be humble with what your findings are. I know if I was a scientist, I would lock into what I believed in. That would be your biases, but I really urge people to be open, because there's definitely false promises that can be out there, and what we're dealing with real people. Real people are trusting what we're doing, and you have to, and fundamentally that's what we're about. And people are talking about what can AI do, what can AI not do. What AI cannot do right now is AI cannot care for people, or AI cannot actually. It might act like it could care for you if you talk to them, and it might care for you more than some of the people that you think are your friends, but it actually doesn't care for you. So that's what humans can do. And so I urge everyone to lead with truth. And this is probably the only way that we're going to advance this area. So I think that's it. Yeah, that's all I have. Any questions?
Yeah, let's go to questions. Folks, yep.
Test. Okay. Is there any way you could see improvement in the way papers are published so that there would be less of these conflicts of interest that you've been talking about?
That's a fantastic question. So before I was an edit. I helped edit a journal. I was a reviewer. I think first of all, you got to cut down the number of You got to cut down the number of journals by 95%. I think you got to cut the number of journals down by 95%. I think you have to change the way promotions are done in universities. I just think there's just so many different ways of doing that. There's too much garbage in journals. In the publish or perish world, it's just too challenging. It's like I think that's one way. I worked in academics. I left academics because there's a lot of challenges that I didn't like. Anybody else have any answers to that question? Because that's a great question, I think.
All right, let's go to the next gentleman.
Yes, thank you very much. Actually, as you were talking, I was thinking perhaps it might be a good idea to have a journal that publishes negative results to solve this incentive problem that you mentioned. And then I looked up the concept online. I saw that there are at least 10 such journals already in existence. There is an explicitly named journal of negative results that, yes, and it focuses on even certain fields of biology. So my question is, why don't you think these journals have had more impact in terms of motivating researchers to be very forthright about whatever the outcome of their research is, whether it's positive or negative, because theoretically they would have destinations to publish negative results as well, and hence they wouldn't be in jeopardy of endangering their academic position.
Sure, I think that's a great question. I mean, and to be transparent, I'm currently not a researcher, but the way I would, I'm not in biology, but what I would say is, like, you publish that paper, that's the end of your last 3 years, and then, then what else? Then what do you do also? And the other thing that you will see is the press does not grab onto that nose negative. How many times are you going to see a New York Times article on a negatively published study? It's nice that they're published. That's very good. But the other thing right now that's changed over the last several years, before a randomized trial is put together, they have to put together like their methods and publish their methods on beforehand, and they have to publish like how they want to do their statistics beforehand. And so those are things right now that are going on. So you're not actually getting p-value dredging and stuff like that. So there are definitely ways of doing that, and I think it's really important that people publish their negative studies so they could help the younger generation or the next postdoc who doesn't go down that path. I just think it's a good thing for people to do, and people should be good to others, and people being good to each other is probably another longevity hack that I think we should all do.
Right here. Yeah, hi, Sarge. Yeah, I used to work at FDA, and there is a rule that results have to be published at clinicaltrials.gov, and hardly the commercial trials, probably only 10% of the results actually ever get published, and they can actually get fined $10,000 a day for not publishing the results within a year, but we've never enforced it basically, and so I think there's got to be a lot more transparency in clinical trials. Before you even begin a trial, you have to release the physician's brochure to the public. And that should be published so that you see what the rationale behind the trial is. And it's true, you get a little bit of data on what the rationale is on clinical trials, but not a lot. And you can't even find out what the substance was that was in the trial half the time. Unless it was, unless they've filed for an INN number, an INN name or something like that. So there's a lot of stuff that, and even at FDA, if a trial's done in Europe, we didn't know what it was. And there's been a lot of instances where, somebody like the famous CD28 trial in London, I mean, that was done in Netherlands before that, and heads blew up there too. But the guy never published it, never said anything about it. And so I think there's a real need to get data out there. I don't care if they publish a paper or not. I think papers, like you said, are a waste of trees. But publish the data. Have a mechanism for publishing the data and getting it out there. All the preclinical data, because you passed a lot of safety tests. Publish it all before you go into humans. There should be a requirement for that. And according to the Nuremberg Protocol and the Helsinki thing, society has to benefit from a clinical trial, not just a drug company or not, and it doesn't benefit if the results aren't published.
Completely agree. I mean, the idea, be transparent. Be transparent in studies and put it out somewhere. I completely agree.
Okay, we have room for, I think, 1 or 2 last questions.
Oh, hi. My name is Feifei. I have a question on what's your opinion on the best way to democratizing providing longevity service into all the primary care? Because a lot of people cannot afford concierge service, and then right now the primary care doctors, they have limited time, and then they are also not trained for longevity. So I'm just curious, for the general public, what would be the best way for them to have access to better preventative care?
I think that's a fantastic question. So what's the best way for the general public to get? I mean, to start off with, the prices have dropped dramatically for the general public to actually take control of of what they want. They can get blood tests ordered for themselves. They can do that. It's just that it's going to be harder for a guide. AI can now start helping that in itself as well. Now when you start getting into advanced diagnostics, like getting a CT angiogram of your heart, that costs money. It's going to be hard to get that. It's going to be hard to get that cheap. If one thinks that an MRI of the body, if an MRI is going to be useful, that's going to take money. But there's AI. It can be extremely helpful for the general public. Last night I was on a panel at the Da Vinci Cafe in Palo Alto, and there's a gentleman named Jesse Levy who's putting together an AI-based platform for longevity, and I think that's a great idea. It's built in with you can have a health coach there. It can tell you your medical problems, and so this is I think a great place for AI to sort of integrate in. And then the problem there is going to end up being, how do you talk? What if you need something now from your primary care doctor? I don't know what the right answer to that is. Probably one of the answers there is the reason that primary care has become, why primary care doctor has to see so many patients a day is going to be reimbursements. Insurance reimbursements for primary care is not very high. You start looking at Medicare rates, they have not gone up. They're actually gone down a little bit. And now private insurance companies have been, they're actually dropping their rates for primary care as well. And so it's just really challenging for someone who just doesn't have the time to do that, to be able to, I wouldn't even say go into longevity, but go into good primary care. It's just, I think, longevity, good primary care is longevity medicine. And now I think that's going to be the fundamentals. Now, maybe in 5 years, there are going to be things that are going to advance, things that can advance our ages. But right now, I don't think so. But AI, I think, is a great answer for that. And the right AI, something that's vetted.
Okay, I think we're done. Thank you so much. All right.